Hi there and welcome back to my Tekkit tips series with a quick addendum to my lift building tip article. So without further ado, this is how small and compact the design can be made with a little more effort. I apologise for not getting to this before posting the last video. So I spoke about a possible orientation bug with the block breakers not working reliably if they were arranged in an east-west direction. Can't seem to replicate that problem now when I go in and again. So this setup seems to work reliably in any orientation. So much simpler now. It's got the deployer directly above a frame motor directly above a block breaker. So in the descent mode, this works very simply by pushing the frames down, destroying it and feeding them back into the deployer with a minimal amount of redstone pneumatic tubing. In the ascent phase, it uses this frame motor to push everything up, and the frame blocks are replaced at the bottom by the deployer over there. Now the good thing about this deployer is it actually deploys not only directly in front of it if the space is vacant, but also the square below that. So it's that square getting filled which this frame can then push up. So if I show it ascending, you'll see it works just as smoothly as before. So it's working reliably on every tick that the frame motor can manage to push the frames. There's a block in place ready for it for the next one to go and move on up. And that will proceed all the way up to the block. You might be able to see way up there is a hard limit on the top of this ascending just to stop it at the top. So that will work fine there. The descent does have a slight quirk because of the minimal amount of wiring I've decided to use here, in that if you set this timer to 0.8 of a second, which is how fast the frame motor can cycle, then the block breaker won't have broken the block that has moved down on the last cycle until it gets the next pulse, which means each pulse that the frame motor gets, every other one, it won't be able to move because the frame will have connected to the block breaker and the thing can't move. So I'll demonstrate that first, just so you can see what the problem is and why you have to have that at a different interval. So at that speed there, it all works perfectly. Okay, great. Well, that solves that problem then. Right, okay, that wasn't doing that before, 5 minutes ago when I tried it. What was happening was it would move down a block and then it would get stuck, and then it would have to wait till the next 0.8 of a second to actually be able to move down. Well, that's great, because when it was having to cycle at twice the frequency, the clicking was very annoying. So you'd have to have that, which works just as neatly. Anything in between works fine as well now. How strange. Okay, so that's it, and I've also set a hard limit on the descent by attaching a redstone torch to the side to a panel block, which simulates what would be needed in the lift in the actual build to send the signals to the computer to tell it which floor the lift had ascended or descended to. Now the advantage of this is that means I could actually put this on the side of the lift rather than having to be in the center, because the arrangement is a bit more asymmetric to the column of blocks that need to be built. So I could have this to one side, the frame out this side for the lift, and therefore that can actually pick the signal up on there, and it just reduces the amount of waste that I'm going to have to need in the design. Okay, that's it for this improved compact frame pusher-upper mechanism, which I'm using for a lift. The other thing I'll just mention is, since the last video, I've also done some work on the aesthetics in here. So I had an idea that I didn't like not having the lift shaft visible. I thought that was quite cool, but I also wanted it safe from players falling down. So, forgive me while I just have to fly up here. I forgot I'd left the lift at the top. And in we go. So the top I've left unprotected, just on the basis of this could be a maintenance area at the top. But if we descend one floor, what you'll see is the lift is protected, and when the lift stops, it automatically opens the door. Now, there's no computer craft or magic wizardry involved there, and it would seem quite simple. You put the redstone torch, send the things around there. But if you did that without anything else, then every time you pass a floor, the lift door would open. So if I was going straight past this floor without it going, it would open that door, and I don't want it to. Whereas if I want it to open this one, if I stop there, it will open the door after a brief pause. And the circuit to do that is relatively simple. It's the signal from the redstone lamp, which is at the back of the lift there, goes into the bundled cable there and out this side. So when the lift arrives on this floor, this redstone wire here will begin to get power. At this point, it will take two paths. First, straight into this, which is a NAND gate. And just in case people aren't aware, a NAND gate will be on if any of its inputs are off. So initially, when it arrives on this floor, this will be on because it won't have had the redstone signal before. The signal will come into here, and that will straight away power these two sides of the NAND gate. Now, that's not enough for this to then turn off this signal. What it also needs is for this input to go on. And what I've done is I've put a repeater in there with a few ticks delay, 2, 3, 4, I think it was 4 ticks delay. Just changed it now, can't remember. So that what it does is this one has a brief delay before it will add the final input needed for the NAND gate to turn off. And then all it is that is used to power these two sticky pistons which push out the lift door effectively. So only if the lift stays on this floor long enough for the signal to have propagated through here and still be on from this direction will the sticky pistons open. So I'll show you that working if I send the lift down a few blocks. So the lift isn't on this floor now, and this redstone signal is off, and the NAND gate then is on because at least one of its inputs is off, so the NAND gate is on. That then is pushing out sticky pistons for the door. If I then ascend the lift, and I'll send it straight past this floor first of all, so the lift is ascending. You can see as it passes the floor, this redstone signal came on, but this one wasn't on long enough whilst that was on for this to ever go off. So the pistons never went out. It's only if the lift descends to the floor and stays there long enough that all three inputs to the NAND gate are on, and therefore the output goes off to open the sticky pistons. Okay, that's it for now, and I'm just going to sit in the lift here whilst I sign off and say, hope you find these series useful. Any comments, feedback would be welcome. See you later. Cheers.